Alright, so you're going to want to go into the POE student shared folder, go under the Unit 2 statics, and then there's this 241 structural design activity that we're going to be looking at, where we're using West Point Bridge Designer software to create an optimized bridge. Our goal is to minimize the cost. That is the overall goal. So there are some constraints that you can look at here in terms of what you have to build and what the span is and all of that. And then it also gives you some information about cost calculations and how those are made. We're first going to open up West Point Bridge Designer, and we want to pick the second edition, not for older computers, but just the second edition. We want to open that up, and then we're going to go through this sort of as a tutorial, and we want to fill in some information. So this is going to be an investigation part where we're looking at how does changing the deck elevation or arch abutments, a pier, cable anchorages, how does that affect your starting cost of your bridge? So if we go into the West Point Bridge Builder, you can hit close on that if it shows up. We're going to create a new bridge design, and it talks a little bit about the design requirement, and we are not participating in a local contest. So this is where we want to start getting our data. If our deck elevation is 24 meters, our cost is $62,700 for the deck, the excavation of the site, the supports, but none of the steel that goes into that truss. So if I click back into the document, I would type in the site cost $62,700 right there. Then we're going to change the deck elevation to 20 meters. So we're just going to drop this down. And now we had to excavate some of that land, so it's going to cost more to start with. However, we're going to need less steel in our truss structure because it's now a shorter bridge. It's not as long. The span is less. So that's kind of what you do. You just go through each of those and you see what the cost is. Now, you can see here this is going to cost significantly more, but look at your span. You have a significantly, less length in terms of the amount of steel that you're going to be using, so the cost for steel is going to be less, but your site cost is more. So that's what the initial, what this is to do, what you're supposed to do there is find that information. This is going to help you when you're actually designing your own truss structure to figure out where your starting point's going to be. This goes into the loading and how the concrete affects it, etc. And then it kind of shows how to place joints and how to place members and that kind of stuff. So that goes through that information. We're actually not going to do this lower part yet, this page 11 and on. That stuff we'll do later when we actually talk about these items. So what you're going to do is you're going to actually create one with a 4 meter span or 4 meter deck elevation and no pier, standard abutments, and we're going to hit next. Medium strength steel, standard truck, and then we're going to do the through truss, the how through truss, and we're all going to do this together. We're going to optimize it. So I'm going to click on next. You can put in your name, and then you can, it basically tells you what you're going to do to design that. I'll let you read that on your own, but I'm going to hit finish. And now we can start placing some joints. So this is our toolbar. We can place joints, members, or we can erase things, or we can just click on items. So I'm going to place these joints. And this basically gives me a template to follow so I can see what I'm doing. And I alternate back and forth because there's a line of symmetry here. So I want these two members to be right next to each other in my member list. That's why I kind of go back and forth. And there we go. Truss is done. We can select on one of these and it tells us what the member number is for each of those. We then want to do a load test. Bring this up a little bit. I'm going to click on this right here. It pulls up the animation and it shows if our bridge passes or fails. And if the truck gets all the way across, it passes. I can click back on the drawing board. And now I can see how to optimize. And this is where you're going to start cutting costs, because you start with $264,000 and we want to reduce that cost. This compression force to strength ratio needs to be as close to 1 without going over as possible. So that's telling us that if our compression force was 500 pounds and our strength was 400 pounds, then we're going to have too much force for it to hold and it will fail. So anything above a 1 will fail. Anything below 1, we have too much strength, so we're not optimizing. So that's one thing. The other thing is the cross-section size. The cross-section size, if it's in compression, we can actually take the material and convert it from a solid bar to a hollow tube so that we move that material further from the pivot, which will allow it to not buckle as easily. So I'm actually going to take all of the items that are in compression and I'm going to put them as a hollow tube. And you can see my cost went down significantly, but I've got to test it. I'm going to make sure that it'll last. Oh, it doesn't even hold itself. So you can see that these are above 1. So now I can go in and I can highlight. I'm just holding down Control when I select multiple ones. And I can increase the member size. And you can see that the colors now aren't as bright red, and it passes. And now these are too big. And now I'm still back at 264, but this is, again, you can see when I start decreasing these and run the load test. Now, I don't like watching the animation every time. It's tedious. I don't want to see that. I don't really care. So I can go under Test and click off Show Animation. And now I can, when I highlight these, reduce these up, when I click on it, it actually just updates it. So I'm going to highlight these and make those bigger. And these right here are too big. Shrink those up a bit. Shrink them up some more. So now I'm at $235. So I've already reduced the cost by $30,000. And I haven't touched any of the bars dimensions. So you want to go through that. Then if you click on your cost calculator, this is kind of what shows you the overall cost of your design. This is the big one right here that will get you. Every time you pick a new product, it's going to cost you $1,000. So if you could group maybe these 140s and 150s together, you're going to save $1,000 even though you're going to bump this up in size. So if you notice, so here's my 140, here's my 150, and here's my tube 140. So look at my cost when I bring this up. See how the cost went down? It went from $235.4 to $234.5. And I actually increased the amount of steel I used. But again, I'm losing one of my products, so I no longer have 2 product lines there. So it's a savings of money. So you want to do that. You want to optimize for that. You want to optimize by material type. Maybe you can group the 180s and 150s and 140s now, and you can change the material type to a stronger material. This is where you get to play around and do your work. Your goal is to get this number below 180,000 for an A+. That's your goal. 180,000 is kind of your target line. What do you need? You need to have this and screenshot this page so I can see your price and make sure that everything passes with your design. You can also go to Report and do a cost calculations report, and you can screenshot this and paste it into a Word document. And then you can also go into Load Test Results to show that they're all okay, and you can screenshot that and put it into your Word document. So you basically have 3 different things that you're going to take screenshots of. This screen, and then your 2 reports, cost calculation and load test results. So hopefully that helps. Have a great 2 days. We'll see you on Monday.